Welcome back everyone and welcome to today's class. Today we're gonna be talking about an advanced C coding technique which is called linked lists. And what is linked lists? Well, it's like a chain of different structures. You need to know beforehand how much memory you should allocate. So if we do like struct my struct ABC and then a number, so this creates 16 structures of the structure type my struct. But what if we only need to use 3 of those? Or if we need to have 200,000 capacity in the database, but maybe only 100 gets used, then we spoil a lot of memory and resources. So storing a database in an array of structs is not the way to go. We could dynamically allocate this array using malloc, but that's not very easy to handle either. But a linked list, that's something else entirely. If we define a struct, let's call it just ABC, and it has 2 values. We have a char of 32, a regular string, and we have an int value that we call I. So these are 2 members of that structure. And so we could create our variable var with any number of size. We could also make it a pointer, and we could use malloc to allocate like size of struct ABC. This counts all the bytes that this structure needs, and we do times 32 or 16 or whatever the number of members is. Could do it like that, but a way better method, more optimized in every single way and easier to handle if you understand how to code this, is making a linked list. So at the end of the structure we have a pointer of this same structure type. So we create a structure named struct ABC, and inside that structure we have a pointer of the type struct ABC that points to the next structure. And when we create another one, this one points to the next structure, and in that way they create a long chain of different structures. So if you need to remove one at the end, you just point the one that is second to the end, then you set the next to 0. And if you want to remove one entry in the middle, then you just choose the one that is right before the one that we want to remove, and you repoint the next to the one after the one that you want to delete. So if you have a number 45, 46, 47, and 46's next is currently pointing towards 47, and we want to remove 46, then we just point the next of 45 towards 47. Okay, it's a quite abstract concept, but it's kind of easy to code. And we're gonna make an example or a code called books.c. And in this code, we are going to include the standard IO library and our main function. And in this database, we are going to store books. They will have two different values each entry, the name of the book and the number of pages. So let's do struct, and I will name it s_book. The s is for the struct. You can name it otherwise if you'd like. And I will have a char with the title, maximum 64 bytes, and an int with the pages. And then at the end, as I showed before, struct sbook next. And we are gonna typedef this one. Typedef is a keyword that creates a new name for any variable type. So instead of struct sbook, I will just call it book with a capital B. Okay, we are also going to need a global variable that is pointing to the very first of these chained books. So we'll do book first, like this. Okay, so first I'm gonna create a function that adds a book to the database. So we'll make this a void function and let's call it add book. We're gonna take two arguments. The first is a character, a char pointer, which will contain the title, and then we'll have an int containing the number of pages, and that should be enough. Okay, so the first thing we need to check is if this is the first book, because the first book we need to handle a little bit differently. I also want to create a variable containing the total number of books. Let's call it num books. And from the beginning, we'll set these global variables. First will be set to 0, and num books also 0. So if there are no first book, then we will use the malloc function in order to allocate the first memory segment. So we'll need a book pointer. Let's call it P. And P will equal malloc size of book, and that's basically 64 plus 4 plus 4. But it might be a different value on another system, if an int might be 8 bytes and so on and so forth. So it's better to use size of than statically assigned values. Okay, so now we have allocated the structure, the memory segment. Now I need to zero it, and I will memset p with zeros, and the number of zeros is the size of book. This is probably not a really necessary step, but I always do that because it has helped me more than it has brought me any problems. Okay, so the allocation is done. We will also increase the number of books. And in addition to this, we will copy the information. So string copy to the P and title. And usually we use a dot between the variable name and the subvariable of the structure. But when we're using a pointer to a structure, then we use this arrow symbol instead. I'm not really sure why it's necessary to differ those two, but this is the way that it's done. Okay, so to the title and from the title, and we are going to copy at most 63 bytes. And we are going to set p pages to the value of pages. And what about next? Well, this is the first and only book, so we'll just set next to a 0. And this should be it. Okay, so if this is not the first book, then we need to loop through the database in order to find the current last book. And we can do it with a for loop. So for let p be equal to first, at first, and we will loop as long as p next is true, and p++ will just move on to the next one. Okay, so now it has looped through every part of our linked list. Now we will create a new pointer. After this loop is done, p is now pointing to the last of the list. So after the loop's done, we will allocate the memory. This time we'll use our new pointer for the same stuff. Let's just copy these lines right here. And we will change p to new in all the different places. Like this. And we will alter the last structure of the list that's next variable will be equal to what? Yes, you're correct. It will be equal to the new. And I forgot something. We do have this first global variable. When we create this one, the first one, we need to point first to our new structure. And same is true here. Same is not true here, because this is not the first one, this is the last one. So this line should do it. And then I believe we are done with this one. So let's try it out. We can't really see much if it works, but we can see if it crashes and if it even compiles. So we'll do add book and we'll put in the Bible. I don't know how many pages, but let's guess 3,500. And let's just add 1 at this point. And we can do a little debugging. Let's print out the title referencing the first title. That should work, right? Let's see what happens. Probably some error. When you're writing this kind of level of advanced code, there's almost every time some kind of error the first time you compile it. As you can see, implicit declaration. That's because we didn't add the header files for malloc. So if we do man3 malloc, we see that it's in the standard library. So let's go back into, and let's not just use nano all the time. This is the advanced part of the course, so we should move over to VI as much as possible. So what's the name? Books.c. And what are we going to do? Right, we'll add an include stdlib.h, save, and memset man3 memset string.h. And it compiled. Interesting. Let's see if it crashes. It works. Isn't that sweet? Just a couple of includes. That was the only thing we needed to fix at this point. Okay, so it can add 1 book. Let's remove those. What did I do? Let's go back. And let us remove those 2 lines and paste them both back like this. But this time we are gonna add something else. Let's add dice man. And what can that be? Perhaps 340. And we would like to print out the second one. I'm not sure if it's possible to do it like this. First, next title. If it works, it would be kind of cool. Let's see. It compiled. Interesting. Okay, so let's see what happens this time we run it. The Bible Dice Man. This is working just fine. Okay, so we can add 1 and we can add 2, probably as many as we'd like. Okay, so adding complete. What's the next thing? Well, we should have something that lists the books, right? So let's call that list books. And we will take one argument, and that will be a search string. So I'm thinking like if the search string is 0, it will just list all the books. And if there is a search string, then we will only list the books which has a title that is equal to the search string. So just an easy kind of search function. And we'll begin by creating a pointer to our books. And yeah, let's start there. And we'll create a for loop where we set p to the what's it called? Oh, it's called first. And I don't think I need this number of books after all. I want to make this as compact as possible. So I'll remove the references to numbooks. And our for loop, p equals first, and we'll loop as long as p next isn't 0, and p++. And what are we going to do when we what are we going to do in each cycle of the loop? Well, if we have a search string, no, if we don't have a search string, search string is 0, or if string compare with search string and p title. So either if the search string is 0 and we just want to list all books, or if the search string matches the title. If any of these are true, then we are simply gonna print out. I don't think we need this one. We'll do like this. So title. No, let's start with pages. Then we can make a good looking column with it. So pages %d, and then we'll add a tab, and then we'll add the title, and %s. Let's put single quotes around the title in case there's a line feed or anything we don't want there. Like this, and we will do p pages and p title. And if I'm not missing or forgetting something, this kinda ought to be enough. So we'll remove these printf statements, and instead we will do list books 0. Okay, I forgot this numbooks line. Remove this and restart. Okay, it compiles. Now we run it. Boom. It listed the Bible. Was this the only one we had? I don't remember. No, we do have 2. Okay, so 4p equals first. Maybe we should do like this instead. I hope it doesn't break. Let's try it. No. Okay, as I thought. Okay, so p equals the first, and as long as p is true, p plus plus. And we will do if p, and I'm not sure that no, that's not it. Okay, so in the first run we set p to first, and p is true. Then we print out the Bible. We increase p. Then p is equal to the second. The problem is that it stops at the penultimate hop. And if we do it like this instead, if p is true, what if we do like this? No, that's not right. And what if we were to change this to p equals p next? At least it compiles. Now it works. Alright. So it didn't like the combination of p++ and the check of p. But this time we move it to p next. And now it prints both of our books. What if we wanted to search for something? Let's search for Dice Man. It finds Dice Man. Great. This time we'll add a little more. We'll add 2 more. What could we add? Can't think of almost any book right now, right out of the top of my head. what about Pippi long stockings? 119 pages. And we will also add Tintin. 340. And around the world in 80 days. 290. Okay, now I have a couple of books. First, we just double check that it can print all these books. It stopped after 2. Why is that? Why is that? After 2 of every possible one. P next. First equals P. And this is the last one. Copy. New title. New next is 0. And P next is new. Is it our print function or let me try something. Let's debug print out first, next, title. Segmentation fault. Because first ought to be this, next ought to be this, next ought to be this, and its title. Something is not right when we add the book, and it probably isn't this one, because the first doesn't seem to be a problem, the second doesn't seem to be a problem either, but what about the third? Then we maybe it's the same thing here that we had in the other one. P equals P next. And we loop as long as P. Segmentation fault again. And what is seg faulting? It must be this line, right? What if we remove one of these instances? Still segmentation fault. What if we L-trace this one? That's S-tracing. S-trace and L-trace are two very good tools when debugging. It follows all the library calls or the syscalls. So we get a better understanding of what's happening. Okay, so we allocate one structure, we zero it out, we string copy the title, then we allocate the second one, we memset it, we string copy, and then it crashes, so it doesn't add the third one. So even if we were to remove this one, will it still crash? And this one. Still crashes at the same spot. Okay. Then we have drawn a little circle around the problem. It should be easier to find. I think it's because of this. P equals first as long as P is true. P next. Let's let this P next be as it is. Okay. Now it doesn't crash anymore. Let's remove these. Dice man. Okay, so let's see if we can add another next statement here, and this time it should print Pippi Longstocking. Okay, so far so good. Now let's remove this printf and we'll do the list books instead. This time it works perfectly fine. Alright. So sometimes you need to tweak your code a little bit before you get the result that you want to. The last thing that we're gonna do to our code is removing one of the items. So let's just copy this whole function, the list books function, because this is going to be quite similar. Let's call this remove book, and we need to reference the book that we want to remove somehow. So I'll keep this search string right here, and we will search for the one that we need, and we need to find the one before that as well. So let's see now. P equals first as long as P, then P next. Let's create one that we will call penultimate hop. So P equals P next. And if that, and if this is true, let's see if we can do pH equals to P, and then P equals to P next. Something like this. And instead of printing, we will do, if we find a match, then we should remove this one. So the penultimate item, its next variable should point to P's next. But only if it's not the last. So if P next, then it should point to P next. If not, 0. Am I thinking right? Well, let's just see. So we'll just in the penultimate, we need to do some, no, probably not. And then we need to return the memory allocation for P. And return. And I don't think we need to make this. Let's make this an int. So we have the possibility of returning if we succeeded or not. So if we don't find a match, we will return 0. If we find a match, we remove it and return 1. But we need to think, if this is the first, we need to handle it differently. If first equals to P, then we will create a new first. And that'll be P next. And if not, then this will happen. But we'll still free the P. What if we remove the last one? Then this should kick in. And if there's one in the middle, everything should be right. Okay. Okay, let's try this out. We are going to add these books, and then we are gonna, let's do it like this. So ret will equal RM book, and we want to remove Pippi Longstockings. Let's print out the return value. And then list all the books. I'm really not sure about this code, but we'll see. At least it compiles. That ought to be worth something, right? Okay, so we get a 1 back. That should mean that we have removed the book. And then we list Bible, Dice Man, Tintin, all around the world, but not Pippi Longstocking. So it works when we remove something in the middle. That's great. What if we were to remove the last one? Around the world in 80 days. Still 1, and this time it prints out Tintin as the last. So that works too. Sometimes I amaze myself. Let's see if we can remove the first one. Yes, we can. Isn't this fantastic? What if we were to remove something that's not a match? No problem. Okay, very, very nice. So what have we learned today? Quite a lot, actually. We have learned how to create a linked list based on a linked list of structures. We have learned how to add something to that list, even if it's the first or any other. We have learned how to list everything in the linked list and even search for specific item. We have learned how to remove something from the list. And it doesn't matter if it's the first or something in the middle or if it's the last. And we have done all this with just one link to each. Usually you have one next and one last, and even more points, but we have done it with only one. And the code works perfectly fine. Thanks for watching, and thanks for today.